Hello, welcome. Let's try to solve another Leetcode problem, 720, longest word in dictionary. So we are giving a word of dictionaries. So this is just like a dictionary. So for each of the word, it is produced like that. First of all, we have a word W, and then we're going to have WO and WOR and WORL and word. If it is like this way, we produced all the words. So we're gonna, output this longest word. So inside it is word. And for the second example, let me make a drawing. So we have A, and from A we can produce the AP, and from AP we can because there is APP we can produce app, and from app we can produce APPL, so APPL, and from this APPL we can produce the apple, and we can also produce applied. So it is produced like this way. But for the banana, we cannot produce it, because from banana, we don't have a B, and we don't have a BA, and we don't have a BAN. So this means we cannot produce this kind of a banana. But we have two words, apply and apple. We're gonna return the lexicographically order, so it's gonna return the apply. Because here it is said we can always return the longest word with the smallest lexicographical order. So this means if there's an apple and apply, we can always return this apple. So as I make the drawing, so this is a typical trie problem. Because for the words representing the English dictionary, so we're gonna return the longest words inside of this word that can be built one character at a time by other words. So we have to build like this, one character at a time. So for the first time it is W, and then WO. It will be like this. So let's start to check if we have a trie data structure, what are we gonna do? So our trie have the insert and have the search, because I will write the trie later. Let's check if we have this trie. So for W in words, key dot insert, so we can insert the word, and now we produced our trie. Now let's just check what kind of words can meet this condition. It means we can prepare a word at each time. So that can be built one character. We can build one character at a time by other words. So we will put all that possible result inside of the result array. So for W in words, we're gonna check if trie.search. Just imagine if we have this insert and search function. Because I will write that later. So if t.search with this W, it means it is inside. So we're going to put the word inside the result array. Now we need to check the result. If the result is empty, so we're going to return an empty string. Because there's no word, so we're going to return an empty string. If there's no answer, so this means if there's no answer, we're going to return empty string. So if there is answer, so we're going to prepare the longest word with the smallest lexicographical order. So we're going to sort the result array. Because there's a lot of conditions, we need a lambda function. So the first one going to be the length. So it is the length of the x, and the second is the lexicographical order. So it is this x is just this word, and this is the length of the word, because it is we're gonna choose the longest first, so we need a negative value. And finally we can return the result 0, and that is exactly our word. For example, it's gonna be the apple, or it's gonna be the world. Now we are going to write this trie data structure. We just needed to finish the insert and the search of this trie. Normally it should work. But for the search, we need to check it should be it must be built one character at a time. So it means while we search the word, for example, we search A and AP, it must be inside. And for this one, B must be inside. If B not inside, it means this word cannot put inside the result. Yeah, so except the banana or other word can put inside the result array. Yeah, now let's just finish writing the trie. So for the trie, I'm gonna write a trie node first. So it's gonna be a trie node, and we're gonna define the function init the trie node. So we're gonna have a self and self.children, so it'll be equal to an empty dictionary, and self.add of word, and so equal to false from beginning. Yeah. Now let's define the trie class. So for the trie, we also have the init. Yeah, let's just prepare the init. So we're gonna prepare a self.root. So the self.root should be equal to the trie node. Now we're gonna prepare the insert, and we're also gonna prepare the search. Yeah. So for the insert, inside it's gonna be a word. So we're gonna check if this word, we're gonna insert this word, and also for the search, so we're gonna search this word. Yeah. So now let's just check, prepare a current variable. It's gonna be the self.root. Now we're gonna check one character by one character. So for C inside the word, we're gonna check if this is C not in. If C is not inside current.children, yeah, so we're gonna build it. So yeah, so we're gonna build a trie node. So current dot children with this C should equal to a trie node. So we're gonna build a new trie node, and then if it is inside, so the current should equal to current children with this C. Yeah, because it is inside, we can directly use this character C. Otherwise, we're gonna build a trie node, build a new trie node. So the K is the character C. Yeah. If we have the K, so we're gonna visit it immediately. We're gonna get the current. So after that, we're gonna prepare the add of word. So current dot add of word should be equal to true. Yeah, because it is the add of the word. Now we're gonna define the search function, and it's gonna be the same from here. Yeah, let me just copy it. So we're gonna prepare a current variable equal to the self.root. If C inside this W, if C, this character C not inside current.children. Yeah, so if it is not inside, we can return a false immediately, because it means we cannot find this word. So for example, for this B, for this character B, yeah, we're gonna check if B is inside self.children or not. Yes, we found it is inside, but if it is inside, so the current should equal to current.children with this character. So we're gonna check if not current.add of word. If this is not add of word, we're gonna return a false. Otherwise, we're gonna return true. So this means for this character B, is this B add of word? So B is not add of word, so we're gonna return false. So this banana will not inside the result array. But for this A, it is inside, and also for app, AP, APPL, and apple and apply also inside. So we're gonna put it inside. Yeah, so this is the entire code. Now let me run it to check if it works. As you can see, it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. Why we use trie? Because for trie, basically for building the trie, for initialization and insert, we're gonna analyze the time complexity. It is the length of the word, and each length of the word, it is just m times n. M is 1000, n is 30. So this is gonna be the time complexity. Now we are also need to consider these areas. If C not inside, for the search function, if C not inside, do we need to check this? Yeah, because if we insert a word, so normally this character should always be inside. Yeah, even if we have a new word, for example, it is not this word, maybe another new word. It is not inside the word dictionary. Maybe this gonna be this is gonna be a false. Otherwise, it should always be true. Let me make a comment just to check. Yeah, as you can see, it works. Yeah, because if we insert the word inside, normally we should not check that, because C should always inside current.children if we were to check it. And the only condition is the add of a word, maybe not inside, because this is according to the longest word in Word that can be built one character at a time. Yeah, now let me submit it to check if it is okay. Yeah, it seems it is okay. It means our analyzation is right. We don't need those 2 lines of code because we don't need to check it, because it will never return false. It is always true. C will always be inside current.children. So this is the entire code for this problem. It is not so difficult. If you are familiar with the trie data structure, you can write the basic like insert or the search. Normally it's gonna be easier for the next step. Thank you for watching. See you next time.